Today we're going to look at introducing linear relations. Recall that the Cartesian plane consists of two axes which divide the plane into four quadrants. So we've got the x-axis that runs horizontally and the y-axis that runs vertically. The four quadrants start in the top right-hand corner. It's the first quadrant, second quadrant, third and fourth. Ordered pairs that look like this. There's brackets that are around the outside. There are two values that are given and separated by a comma. The first value describes the horizontal position, the x-axis value, and the second value describes the vertical position, the y-axis value of any of these points on the plane. So all of these green points here labelled are points on the plane. So we have, for example, this point is on the y-axis. It's given its coordinates as 0, 2, because it's a 0 here on the x-axis and 2 up on the y-axis. This point here, 3, 1, is 3 along on the x-axis and 1 up on the y-axis. This point here is 2 along on the x-axis and 4 down on the y-axis. It's at the point -4 on the y-axis. This point here is on the x-axis. It's -3 on the x-axis and it's 0 on the y-axis because it's on that x-axis there. A linear relation is a set of ordered pairs that when graphed give a straight line. So we've got the word linear, it means straight line. Linear relations have rules that can be of either of these two forms. This is probably the more common form that you'll see, and we'll discuss it a little bit more later. Y equals mx plus c, so that means that we've got y equals some number, some constant, times x plus another constant, or we can have ax plus by equals d. So a is a coefficient of x, it's another one constant, b is another constant, could be different, could be the same, and d is another constant again. So the x and y intercepts are the points where the line intersects the axis. So the x-intercept is intercepting the x-axis, it intersects the x-axis, and the y-intercept intersects the y-axis. So for example, if we've got this linear relation here, 4x plus 2y equals 8, we can express that exactly the same, exact same linear relation in the y equals mx plus c form, y equals -2x plus 4, and we just do that by rearranging. You can see that if I subtract the 4x from both sides, then this becomes 2y is equal to -4x plus 8, and then if I divide both sides by 2, if I divide 2y by 2, I just get the y, and if I divide this whole side by 2, I get -2x plus 4. So that's exactly the same. I've just rearranged it into a different format from this form to this form here. One way we can graph if I've got a linear relation like this, is to use a table of values. So if I just say x is going to be between -1 and 3, so -1, 0, 1, 2 and 3, I can substitute -1 into here to find what the y value will be. So -2 times -1 is +2, +2 plus 4 is 6 for our y value there. So that's what y would equal when x is -1. And when x is 0, -2 times 0 is 0 plus 4 is 4, and so on for the rest of the values in the table. The y-intercept is going to be when x is 0. So when x is 0, we're going to intersect the y-axis. So x is 0 here, so the y-intercept is going to be at 0, 4. The x-intercept is going to be when the y value is 0. So when y is 0, then our x, it'll be crossing the x-axis. So our value here for the x-intercept is going to be 2, 0. Here's this linear relation graphed in green here. Notice there are two arrows on the ends. That's because the linear relation keeps going, even though we haven't graphed the whole lot. We plotted each of these points. So I plotted -1, 6 here, plotted 0, 4, 1, 2, 2, 0, and 3, negative 2, and they joining them up, they draw a straight line. And you can see the y-intercept here intersecting the y-axis. This is the y-axis here, so it's the y-intercept. And this is the x-intercept, where it's crossing the x-axis here. If we look at an example, the example reads, using the values of x between 3, this should be greater than or equal to as well, or less than or equal to. So using the values negative 3, x is between negative 3 and 3, that's what this symbol means, or this kind of notation means. It's essentially saying, well, x is going to be greater than negative 3, greater than or equal to negative 3, and x is going to be less than or equal to 3. So x is going to be in between and including these two numbers, negative 3 and 3. So using these values, construct a table of values and plot a graph of the linear relation y equals negative 2x plus 2. Then we need to give the coordinates of the x-intercept and y-intercept. So here I've drawn up the table of values. Firstly, I've drawn up my table and given the x values between negative 3 and 3, as it says here. So I've done negative 3, negative 2, negative 1, 0, 1, 2, 3. There are x values there. To get the y values, all I've done is substitute in our x value into our linear relation. So for example, for negative 3, I know y equals negative 2x plus 2. That's negative 2 times negative 3 plus 2, which is 6 plus 2, which is 8. So I've got that value there, and I can just use my calculator to plug in all of those numbers, repeat that calculation, and get all of the y values out. Once I've got each of those points, I can draw up my Cartesian plane with my y-axis and x-axis. I know that my x values need to be between negative 3 and 3, so I've made sure I've included those on the graph. And I know that my y values need to be between negative 4 and 8, so I've included those values on the graph. I've plotted each of those points on my graph, joined them with a straight line, and included arrows on the ends. One thing I should do as well is I should label my line and say what rule this is and what linear relation is. So I should write y equals negative 2x plus 2 next to the line. I can see either from here or from here what my x and y intercepts are going to be. This is my y-intercept here, and this is my x-intercept here, where it intercepts the x-axis. So my y-intercept is 0, 2, 0, 2, and my x-intercept is 1, 0, 1, 0. Last example, rearrange these linear equations in the form in brackets. So we've been given here in the form ax plus by equals d, and we need to rearrange as y equals mx plus c, and this is in the form y equals mx plus c, and we need to convert it back to ax plus by equals d. So for our first one, 4x plus 2y equals 10, we need to get that looking like y equals mx plus c. So my aim is to essentially remove everything from the side that has y on it, so I just get y by itself with no coefficients. So I can first remove the 4x from this side, so I can take 4x from both sides, and I get 2y equals negative 4x plus 10. So this is looking more like our form y equals mx plus c, because I've got some y stuff, I've got some mx stuff, and I've got some c stuff kind of there. So it's in that sort of form already, but y isn't by itself, so I need to divide both sides by 2, because if I divide 2y by 2, I will get just y. So dividing 2y by 2, I get y. Now I need to divide the whole side by 2, the whole lot by 2. So it means I need to divide this by 2 and this by 2. So negative 4 x divided by 2 is the same as negative 2x, and 10 divided by 2 is 5. So now I'm left with that form, y equals mx plus c, y equals some number times x plus another number, and I've answered the question, I've put it in that form. Lastly, putting this in our form ax plus by equals d, I've got it in y equals mx plus c, it means I need to have the x's and y's all on the one side. So if I have 4x on this side, but I need it over this side, I can subtract 4x from both sides. If I take 4x plus from both sides, I get negative 4x plus y. And I have negative 7 on this side. So we can see that's in our form ax plus by equals d, where d is negative 7. B is actually going to be 1. There's no coefficient there, so it's just 1 times y. And my value for a is negative 4.